Hello, my name is Gabrielle Benabdallah, and I am a PhD candidate in the Department of Human-Centered Design and Engineering at the University of Washington in Seattle. And today I present on behalf of my co-author Nadya and myself our paper on technical mentality, principles for HCI research and practice. Technical mentality is a concept developed by the French philosopher Gilbert Simondon in the second half of the 20th century. And through it, Simondon expressed a view of society that would integrate technology into culture rather than merely instrumentalizing it or anthropomorphizing it. And Simondon's diagnosis is still accurate more than 70 years later. There seems to be two prevailing attitudes toward technology today. On the one hand, computer systems and consumer electronics are caught within a consumer culture that cultivates convenience rather than care. And on the other, there is a kind of anthropomorphism of certain systems, such as AI systems, which some fear are going to continue perpetuating harm as they have done in the past, or in more extreme cases, take over, whereas others view these systems as holding the promise of solving almost every problem. And both attitudes are expressions of the same reality, according to Simondon, which is a lack of understanding of the machine and of technical systems in general. Simondon writes that the most powerful cause of alienation in the contemporary world resides in this misunderstanding of the machine, which is not an alienation caused by the machine, but by the non-knowledge of its nature and essence. So Simondon advocated for a more complete humanistic culture that could account for the human content in technology instead of alienating it by othering technology. Decades before scholars and thinkers became interested in the non-human, Simondon was very much into reclaiming the particular modes of existence of technical non-humans, and how the only way to create full and healthy accounts of human experience was to fully engage with the existence of these technical non-humans. Technical mentality, which makes a lot of complex arguments, could be summarized as an engagement with the, quote, inner lives of technical systems. And by that, Simondon meant their proper mode of existence, which is to be found in their mechanisms and mode of operation. That is how machines and technical systems work. Technical mentality is therefore not a technocratic mentality, which would further instrumentalize technology, but rather a mentality that recognizes and respects or values the human content in technical systems, which is crystallized in their mechanisms. Machines and computer systems are, in this view, expressions of human labor, ingeniousness, and inventiveness. But these systems and machines, as opposed to the works of culture, such as art, remain opaque to most, closed, only known through their socialized layer, that is, their interface. Machines and technical systems are, in other words, black boxed. Their operations are hidden. And according to Simondon, this tendency to hide the mechanisms and operations of technical systems has deep roots into the Western intellectual legacy. It can be traced back to ancient Greece, where the philosopher Aristotle developed an ontological model called hylomorphism. The hylomorphism is an ontological model that is a model that describes how things come to be, by which states that beings come from a combination of form and matter. Aristotle's canonical example is a fabrication example. It is the making of bricks. So here matter, clay, meets form, in this case mold, to make a brick. And in this model, the active principle is considered to be form, whereas matter is passive. And this ontological model is so powerful and enduring that a lot of fabrication systems today are still premised on it. Computer numerical control, or CNC, machines, for instance, also imply the meaning of a form, in this case, a mathematically specified geometry, with materials, which are often treated as uniform and compliant, which they often are, through machine operations, which are often obscured or hidden in machine code. And together they yield the object or the technical being. For Simondon, the helomorphic model is a very poor and underspecified account of how bricks are actually made, and by extension of how beings come to be. The clay that makes the brick, for instance, does not occur spontaneously in nature. It is itself made. It is harvested from the marsh, then cleaned of debris, then dried and sifted, then mixed with water until achieving the right consistency and plastic qualities. The mold is, of course, also made. It's not the Platonic ideal of form, but something that is instantiated in the world, that is defined by materials and material properties, a plan and a process. There's first a gathering of materials, a fabrication phase, then a post-processing phase, all of which contain multiple design decisions. Simondon calls these processes of making form and matter chains of operation. And so, according to his account, it's not form and matter that make beings, but the work, the operations, the processes by which they are first made, then combined, that make being. And in this case, the brick, which is considered a technical being. So technical mentality at a fundamental level is an approach to systems and machines that seeks to engage with their hidden mechanisms and operations. That is, to investigate what Simondon calls the dark zone of the helomorphic schema, and which we would call in technologist parlance, black boxes. So the philosophical project of technical mentality is to open up these black boxes. It is to engage with the inner lives of technical systems, their proper mode of existence, which is their mechanisms or operations. And Simondon's proposal for developing a more sustainable relationship with technology is to develop what he calls open machines or open systems, which are reconfigurable and extensible, and that allow for some level of legibility and also intervention from users. And so what might the open machine or open systems look like? This is the part of the paper where we move away from describing Simondon's position to applying his philosophy to real-world systems, and where we begin the practical work of formalizing his philosophy into a design project. And so the example we discuss in the paper is a system that comes from our lab, and which is called Imprimer. Imprimer is a system that uses computational notebooks to control a CNC milling machine. We encourage you to read the paper to learn more about the system, but to summarize, Imprimer is a good expression of technical mentality because it allows the maker to engage directly with machine operations by writing code, whereas traditional CNC milling workflows make the machine operations hard to access. Imprimer allows direct engagement with machine operations. It puts them front and center of computational notebooks where they can be read, understood, and manipulated. By using computational notebooks, Imprimer also makes the code that controls the machine easy to annotate, share, and extend. Too often, machine code only lives on the hard drive of one device and is difficult to access, and when it can be accessed, it's difficult to make sense of. By leveraging the attributes of literate programming, such as natural language annotation and the integration of graphics, Imprimer makes the code visible, easier to understand, and visualize and share. Technical mentality definitely deserves a longer conversation, and we invite you to read the paper for a longer discussion of its arguments. Or even to read the original article, Technical Mentality, made available online by Parisia Journal. But here we want to wrap up this discussion by sharing 4 propositional and provisional principles that start formalizing Simondon's vision into a design program. These principles are extension, integration, legibility, and expression. Extension refers to the design strategies that make systems able to be modified, extended, repaired, and maintained. Integration refers to the design strategies that take into account the existing natural and artificial ecosystems in which a particular technology exists and will exist. Legibility refers to the design strategy that make the mechanisms of technical operations of systems visible and intelligible. And finally, expression refers to the design strategies that encourage exploration and experimentation with the operation and mechanisms of systems. Please see our paper for a more extensive discussion of each of these principles. So to conclude, we want to propose technical mentality as a possible orientation for HCI research and practice that is grounded in a relational, materially attuned, and labor-oriented ontology, so that the researchers and practitioners of this community can help foster a more sustainable relationship with technology, and a more sustainable culture of care and direct knowledge of technology. Thank you.